So product constancy is basically a concept like let's say speed into time is one simple example, is equals to distance, right? So basically I am multiplying two things to get a third thing. So the statement would be like, imagine this, if I say speed increased by 20%, right? By what percent should the time decrease such that we cover the same distance? So that's like, let me take a simpler example on this. I'll come back to this again. Let me take a simpler example. Let's assume that a pen cost 1 rupee, okay? And I have total 10 rupees. So how many pens can I, so price of one pen is 1 rupee, and how many pens can I buy with 10 rupees? That is 10 pens, right? How would I get it? Price into quantity will be the total. So I have 1 rupee is the cost of a pen and quantity is 10 pens, so that will take away 10 rupees. Let's imagine that something happened and the price of a pen went up to 2 rupees. Now if I ask you, how many pens can I buy spending the same money which I was spending earlier, right? The total will not change, it is still 10 rupees. So 2 rupees into the new quantity, I can still spend a whole 10 rupees, so that will give me Q2 as 5 pens. If you see here, the product constancy concept is that I am multiplying two things, something variable 1 into variable 2, and I am getting an output total something. Even in the question they would give you a clue where it says this is same. Something has happened with one of this variable, automatically the other will have to adjust itself so that the product is still the same, right? Understand this, right? So because earlier the price was 1 rupee, I was able to buy 10 pens for 10 rupees. Now because the price has gone up to 2 rupees, I automatically had to adjust my quantity, cut it down from 10 to 5 to spend the same amount. That's the word called constant, right? I'm not changing the total, but I'm changing the things within them internally to maintain the same consistent output as the total. Similar what I was talking here also. Let's say I was going at a speed of 10 kilometers per hour for 10 hours. How much distance would I cover? 100 kilometers. If I ask you the speed has increased by 100%, let's say speed has increased by 100%. What does that mean? My speed is now 20 kilometers per hour, right? Now, if I am covering the same distance, how much time would I take? Automatically I take 20 into 5. See, the total product is same, 10 and 10, 100 and 100, but because the speed has increased, automatically my time will decrease, right? That's the variable 1 into variable 2 is total. So one of them will automatically increase, then the other has to decrease to maintain the product of it same. So that's basically the product constancy. Sometimes the questions would focus as like, if the speed has increased by 100%, what happened to my time? It decreased by 50% if you observe carefully. 10 to 5 hours. So this is my initial value and this is my final value. If I do it, I'll get minus 50% for that. They'll ask you questions like that. Similarly, if I say if my pen price increased from 1 to 2 rupees, that is 100% up, right? By what percent did my quantity go down? Again same, right? 10 to 5, again it is minus 50%. So let's look at a shortcut for this. I don't really prefer this, but I'll still talk about it. I'll also solve the normal way in the examples. I'll show you both. I'll tell you why my preference is a particular thing. So the formula says something like, when one factor of a product is increased by p%, then the other factor will be decreased by p by 100 plus p into 100. If you remember earlier case, I was taking a case where the speed increased from 10 kilometers per hour to 20, that is plus 100%, right? When speed increased by 100%, so p is basically 100, then the other factor, that is time, will automatically decrease by 100 by 100 plus 100, that's p by 100 plus p into 100 percentage, right? This will be the other factor will be decreased by p by 100 plus p into 100 percentage. So 100 by 200, that's 1 by 2 into 100 is basically 50%. You see this? So if my speed is one of the variable is increased by p%, in this case 100%, the other variable will automatically decrease by p by 100 plus p into 100%. I've just plugged in 100, I'm getting minus 50, right? So that's what we saw. That's what we saw here, right? So plus 100%, the other quantity is minus 50, such that the distance is same. Even in this case, price and pen and the quantity also I'm getting same, plus 100% minus 50% to maintain the overall amount same. Similarly, if one product is decreased by p%, right, let's say the speed has gone down by p%, then the other factor will be increased by, if speed has gone down, let's say down by 20%, I'm just taking an example. If speed of a vehicle has decreased by 20%, how much more time will it take? In percentage I'm talking, it will be automatically p by the time, p by 100 minus p into 100, that will give me 20 by 80 into 100, that is 25%. This will be plus, because I am decreasing it, this will increase. So if the speed of a person decreases by 20%, the person will take 25% longer time to complete the same distance, right? That's what these formulas are for, right? P by 100 plus p into 100 for, if increase, then the decrease will be this. If it is decreased, then this will be the increase, right? So this is a shortcut that you can use. I'll show the normal way to solve first. For example, here it says the price of a sugar increases by 25%. By what percent should the consumption be decreased in order to maintain the same expenditure, right? The total has to be same. That's what the question is saying. Let's take this. What is this? Price into quantity consumed is equals to total expenditure, right? So let's assume that for this case, that's case 1, the normal price 1 is 100 rupees per kg, and I eat 100 kgs, or the family, whatever the right? So 100 rupees per kg is the cost and 100 kgs is what the consumption was. This is all earlier, before the price increase. What is the total expenditure? 100 into 100, right? 100 rupees per kg into 100 kgs would be 10,000 rupees. So I have to spend 10,000 rupees to buy 100 kgs of sugar for this price. What happened now? Case 2, the price has increased by 25%, right? So earlier it was 100 rupees, now it should be 125. How? 100 plus 25% of 100. So 25% of 100 is 25, 100 plus 25 is 125. Now per kg the price is 125 rupees. What is the quantity I can consume? What is the condition? The total expenditure must be same. It should still be 10,000. So how would I do it? Total expenditure is equals to price 2 into quantity 2. That is 125 per kg into Q2 is 10,000. Right? So this will be what? 80. 125 into 80 I will get. 125 is 1000. So 80. So that means I can consume 80 kgs. Right? So now it's asking by what percent should the consumption be decreased in order to maintain the same expenditure. It's asking in percentage. I was earlier consuming 100 kgs. What am I consuming now? With this price change such that my expenditure is same, I am consuming 80 kgs. So 180. So what is the percentage change? This was my initial consumption. This is my final consumption. Final minus initial by initial to 100, that will be minus 20 by 100 into 100 is minus 20. So that's basically I have to decrease by 20%, right? This is what we are doing here. I just repeat it briefly again. It's saying that I'm assuming 100 and 100. You can take 10 and 10, 1 and 1, x, y, x, x, anything is fine. There's no problem with that. Even I can take 100 and 10 also here. So it's just some random numbers you're taking. Don't worry about that. 100 and 100, I'm just taking so that the percentage calculation will be easy. So 100 into 100, I was paying 10,000 rupees. Now in this case, what am I doing? The price has increased by 25%, that is 100 plus 25% of 100. So that is going to be 125 rupees per kg. The total expenditure has to be same even in this case. So that has to be 10,000. So I am finding Q2 by using this total expenditure is price into quantity. That will give me that I consumed 80 kgs to maintain same amount being spent on sugar. So they are asking what is the percentage decrease. So I do initial minus final initial 100 kgs to 80 kgs. That will give me 20%. Now the shortcut I was talking earlier, right? If you remember, if one quantity is increased by p percentage, the other will be decreased by p by 100 plus p into 100 percentage. If you see, the price of a sugar went up by 25%. So p is 25. That means the consumption would decrease by 25 by 100 plus 25 into 100. So 100 plus 25 is 125. 25 by 125 into 100. So 25 ones are 25 5s are, that will give me 20%, right? 5 ones are 520. So because one quantity has gone up by 25, the other has to go down by P by 100 plus P into 100, that will give me 20%. Right? This is faster and better in a way if you are confident about the formula and get it. What happens sometimes is question like this. They will say if the price of a petrol increases by 20% and the Raj intends to spend only an additional 10% on petrol, by how much percentage will he reduce? Here, the total expenditure is not same. They are allowing it to go up by a 10%, right? So let's take a case 1. If the price of petrol increases by 20%, let me assume the earlier price was 100 rupees per liter and I was consuming 100 liters, or Raj was consuming 100 liters. What was the total expenditure on petrol? I will be 100 into 100, that will be 10,000 rupees was spent on the petrol by Raj in a month. What's happening now after the price hike? The petrol price has gone up by 20%. That means 100 plus 20% of 100. That will make it 120 rupees per liter. I don't know how much of a consumption is happening. That's what I need to find, right? So that I can find by how much percentage he reduced the quantity. What's happening to the total expenditure also? It's not the same. Earlier example it was same because it said it had to be maintained. But what is this happening here? It says Raj intends to spend only an additional 10% on petrol. He is okay to spend additional 10% on whatever he was spending earlier. He was spending 10,000 earlier on petrol. Now he is okay to spend another 10% on it. Right? If you remember the earlier case, the question was talking about maintaining the same expenditure. If that is the case, I should have started, or I would have taken total expenditure in this case also as 10,000 only. But here there is an additional clue which says Raj intends to spend an additional 10% on petrol. So he was spending 10,000 earlier. 10% of 10,000 is 1,000. So now he is ready to spend 11,000 rupees, right, on petrol. This decision he has taken because of the hike in the price. It's okay. So what is now I have to do? Total expenditure is 11,000 equals to 120 rupees per liter into quantity 2 is what I need to find. So quantity 2 will be 11,000 by 120. These are not coming out to be simple numbers, but that's okay. 12 9s are 108 and then 20, 12 1s are, then I get 20, sorry 12 1s are 12 and 8, 12 7s are 84, right? Or 12 6 are, which will be like 91.66. Yeah, I'm getting 91.66 liters. That's the consumption I'm having in this case, right? Now the initial value was 100 liters, the final value is this. Now I need to do percentage change, final minus initial by initial into 100, it will simply turn out to be minus 8.33%. If you see this, right, I don't write this actually in real life when I solve because the initial value is 100, I always know they'll get cancelled. So simply subtract this minus this. That's the reason why I'll also go with 100. So when I see 100 and this is 91.66, the difference itself should be my percentage change. I don't need to do by something into something because 100 get cancelled. So 100 and 91.66, the difference is 8.33. It's a drop of 8.33%. Right? As simple as it. What's wrong with this? I mean, this question, if you just blindly apply this formula, P increased by 20%, right? Price went up by 20%. So then what should happen to the quantity? It should decrease by P by 100 plus P into 100. Then what is happening? You will get 20 by 100 plus 20, right, into 100, and that is going to give me what? 20 by 120 is 1 by 6 into 100. That's going to say that there is a drop of 16.66%, but that's not correct, right? If you observe carefully, that's not the correct one. So for that reason, I would recommend you to not just go blindly with this formula, right? This works when the overall value should be same. I'm not denying that. If the overall value is same, that is the total expenditure or whatever the total quantity is, the product of two things have to be same, then yes, you can use this. But I feel that irrespective of the case, if you understand the concept, the fundamental concept, this is going to give you answer for sure, and it won't take you too much of time either. So I generally prefer this method for this reason, so that I can solve any question without making a mistake.